Hello, my name is Constance Gorman, and today I'm going to demonstrate my screencast number 3 using Google Classroom. The title of this is kind of long. I just put the title on. It's using tree diagrams and probabilities to assess defects in the manufacturing process. I know it was cut off, but I'm still on the learning curve here. And so this is a warm-up problem that I am presenting. The warm-up problem states, do you ever wonder if the shoes you buy or the car you drive are checked for defects? So that's like an intro question because I think most students would be able to relate to that. And the very first step I instruct the students to do is to begin watching this video. And this video acts as a backdrop and to set the mood and to get them really familiar or at least comfortable with the manufacturing process. It's more just an intro to set the mood. So here it is. So this is a very short video just to get them into the mood, like I said. So then the next step that I want them to do is to read an article below to learn how manufacturers use statistics to determine their liability exposure in the manufacturing process from defects. So this article is somewhat higher level. There may be a couple students that may not be able to get through it just because, it's a little detail oriented, but right away it talks about how they use statistics to determine the liability from defects. And that's what our class is, AP Statistics. So that's the second step that they would do. And then once they read that article, the next step is for the students to construct their own tree diagram to solve this word problem. So the word problem states, suppose a factory is producing light bulbs. And I chose light bulbs because, you don't have any socioeconomic barriers for understanding this type of problem. Everybody uses light bulbs, so I thought it would be a good choice. So suppose a factory is producing light bulbs. The probability that any light bulb is defective is 0.01 and 0.99 that any light bulb is made correctly. So if it's defective, the probability is 0.01. If it's in good shape, the probability that it is 0.99. In other words, 99 times out of 100, 99 light bulbs out of 100 would be perfect. And if they're defective, it's just 1 out of 100. So the word problem goes on. Justin, the light bulb tester, is testing light bulbs at random. What is the probability that Justin finds the first 3 bulbs are not defective? And that's an open-ended question. So it gives them an opportunity to think about it. And then the other open-ended question is, what is the probability that Justin will find just 1 bulb is defective? And then the next sentence, I ask their opinion. because usually when people are asked their opinion, it's not a high stress situation, so I think it would calm them down, give them, allow them to relax. And I asked their opinion, do you think the manufacturer has a big financial risk of losing money if the profit of one light bulb is $1? Or what if the profit on a light bulb is $5? So even though I'm asking their opinion, the questions are somewhat high level because now you're tying in the economics of the manufacturing process along with the statistical analysis. So what I'm doing with this warm-up problem is allowing the students to apply what they know about tree diagrams to answer these questions. Okay, so now I provide a hint, because most students, I don't know one student that likes word problems, and there's some that absolutely just panic. But, in statistics, no matter if it's AP or just regular statistics, it's nothing but word problems. So I do diffuse the anxiety by offering a hint for students that don't know how to get started. So we go back into some things that we've done before. If you recall, there's the random coin toss, and hopefully the student would select 3 tosses, because in this case with this word problem, there's 3 events, and they would toss the coin and see how the path, just one path would be created. And then if they do another trial, they would do it again and see that there's another path. But if a student is an average student and they don't really need the random coin toss, then they may want to take a look at a completed coin toss tree diagram along with the probabilities. And that would help the average student to get started with this new application. And then for the students that totally understand tree diagrams, they would most likely read this article and then go on to solve the problem. So in my estimation, this warm-up problem, for the Brainiac kids, might take about 10 minutes, 15 minutes tops if they read the article. Other students that are average or struggling, they may take between 20 and 25 minutes, which may seem like a long time if it's a warm-up problem, but I've run into the situation where schools at times have A days and B days, and the class times are 2 hours long. So this type of warm-up problem would give the teacher an opportunity to maybe take attendance, answer questions. So on the Google Classroom, the students can ask questions, as it relates to as they're solving the problem. So there's going to be plenty of time for them to solve this. So that is my demonstration.